Hello. Before watching this video, make sure you choose the highest quality setting that your computer will allow you to have. Hello students. So in this video we're going to learn how to approach a passage in the ACT Science portion. So here's a sample passage from a previous release ACT test. And as you look, there's lots of graphs, or sometimes there's data tables, there's lots of text. Now remember, we said the ACT Science portion is the last portion of the test, so you're going to be tired. There's about 40 questions for 35 minutes, so there's not a lot of time. So, tip number 1, don't read everything in the passage. Did you hear me right? You absolutely did. Don't read everything in the passage. When you approach a passage like this, all you need to do is read the introduction, which will be just that first little paragraph. Sometimes will even just be a couple of sentences to give you a little bit of background information. Don't read anything else. Just make sure you go straight to the questions after that. So pause this video right now, take a minute, and read this introductory paragraph. Alright, hopefully you read that paragraph. Now we're going to move on, okay, but to the questions. But before I do, I want to say this. Tip number 2, be comfortable with subjects that you've never heard anything about. When I read this passage, okay, and I'm a high school science teacher for over 10 years, I have never in my life read anything about volcanoes and Jupiter's moons, okay? But guess what? To answer all of these questions, I just need to be able to read these graphs, okay? I don't need to have prior knowledge about volcanoes and Jupiter's moons, because the truth is, I don't, and probably pretty much all the teenagers, maybe with the very rare exception of a few, had any knowledge about volcanoes and Jupiter's moons, okay? And yet, you can still answer the questions because it's all about data analysis. Remember, little scientific fact knowledge, more about scientific thinking, okay? All right. Now, tip number 3, what you do need to be careful about is to read the data tables and the graphs and the images very carefully. Okay, so pay attention to things like titles, x-axis, y-axis, units. Okay, the name of the graphs, figure 1, figure 2, any keys, anything like that that you're given, that will be the important information you need to pay attention to. All right, so enough introduction. Let's skip straight into the questions. So here's the first question of this passage. Number 8 says that the wavelengths used in study 1, as the wavelength of the light increases, the reflectances of the S allotropes and of SO2 do which of the following? So hopefully you remember from the introduction that S means sulfur and allotropes means different forms. Okay, so those terms were defined for you. So remember that almost all of the difficult terms in the ACT will be defined for you. Little prior knowledge of scientific facts, more about scientific thinking, okay? And then as I scan the answers really quick, it's pretty much asking me if they're just increasing or decreasing, okay? Now, tip number 4, okay? Make sure you're looking at the right study or graph. So that's a study number 1. So don't go look at study number 2 or number 3. Pay attention to what you're looking at. Okay, so let's go look at study number 1. So study number 1 right there, I'm going to look for a graph that mentions S allotropes and SO2. Okay, awesome. So here, there's that graph right there, and there's the reflectance of that graph. All right, so what is happening with, first of all, if we look at question 8, just the S allotropes. Okay, just the S allotropes. Well, all of these S allotropes here, white, orange, red, and brown of sulfur, they all seem to be increasing. Okay, they kind of slow down, but they keep increasing. SO2 goes up, and then it goes down a little bit. So when I look at the answer choices, the only possible answer is G. There we go. I just answered the first question, again, without having to read the whole passage. Let's look at the next question. According to study 3, compared with the corresponding average reflectance for small plumes, Large plumes on Io have an average reflectance at a given wavelength that is blank. So let's break down this question. Okay, first of all, study 3, which happens to be right here next to us. So that's awesome. And then I'm thinking, compared to the reflectance of the small plumes, what are the large plumes like? What are their reflectance like? What if I don't know what reflectance is? Doesn't matter. It's on the y-axis for you right here. So the large are the solid lines and the small are the dotted lines. The large are always smaller than the small. It's kind of backwards, huh? So the only possible answer is C, always lower. Again, just reading the graphs and the data, okay? Number 10. According to study 1, the reflectance of white sulfur at a wavelength of 0.40 weird letter M is closest to which of the following? Again, you don't need to know what that weird letter is to answer this question. So I'm looking at study 1, YS, and then 0.40. So let's look at study 1. I'm going to look at YS, and then 0.40 is going to be like around here. So my reflectance should be close to 0.2. So letter H is my answer. Let's look at number 11. According to studies 1 and 2, so I got to pay attention to 2 different things. The crater floor of the volcano Peale, I guess that's how you say that, doesn't really matter, has reflectances most similar to which of the following sulfur allotropes? So I got to look for something on volcano Peale. Studies 1 and 2. So when I look at the graphs, so the left side here I got study 1, and then part of study 1 on top, and then study 2 down here. So when I look at the graphs, here's something about Peale, okay? Right there. So when I look at this, it just seems to go in this gentle upward curve. Now, which of the allotropes matches? Because that's what the question was asking, remember. I'm looking for Peale, and then which allotrope is most similar to it? Okay, Peale reflectance most similar to which of the following allotropes? Well, this upward gentle curve is going to be most similar to brown sulfur. So I look at my answers, brown sulfur. There it is. It's as simple as that. All right, let's look at our last couple of questions here. If the average reflectances for large plumes and for small plumes had been measured at a wavelength of 0.61 weird letter M in study 3, those reflectances would have been closest to which of the following? Whoa, so I gotta break this down. So first of all, I'm looking at study 3, and I'm looking for large plumes and small plumes at 0.61. So if I go up to study 3, 0.61 is going to be beyond the graph. So they're asking me to extrapolate, which means predict what's going to happen based on the pattern that I already see. Okay? So large plume is at about, what do we think? Well, close to 0.5. And small plume is pretty close to 0.9. So at 0.61, we can estimate it's going to be around 0.5 for large, 0.9 for small. So let's look 0.5 for large, 0.5 for small. Letter H right here. That's awesome. It's easy as that. Let's look at our last question. According to study 1, YS has a reflectance of 0.98 at a wavelength of 0.60 weird letter M. Okay, this means that YS reflects. Now it gives me the different options here: 2% or 98% at 0.60 wavelength light that strikes its surface, or all the visible light that strikes its surface. So when I go back to study 1, the graph doesn't tell me what reflectance is, okay? So I may have to read, and on occasion there will be a question that you have to read a little bit deeper. Okay, so I start scanning really quick for something that tells me what reflectance is. So right here, italicize. Reflectance is the fraction of light striking a surface that is reflected by the surface. So 0.98 is going to be 98%, okay, because it's everything that's being reflected. So I'm going to keep reading here, and it says the 4 allotropes of sulfur, I've got the 4 colors, and of a sulfur compound, SO2. Then it says reflectances were measured at visible light wavelengths between 0.35 and 0.60. So it's not saying all the visible light, just between these specific wavelengths. So we're getting specific measures. Okay? So if we go back to question 13, we're either between 98% at 0.60 or 98% of all visible light. And the answer would be 98% at 0.60. Okay? So there we go. We're done with this passage. Okay, now here's the whole point here. We were able to answer several questions, okay, without having to read a whole lot. So you just went straight to the question, looked at the graph, answered the question. Next question, look at the graph, answer the question. And you go like that because you've got 40 questions to do in 35 minutes. It's not a lot of time. And again, remember, it's going to be at the end of the ACT, so you're going to be tired, you're going to be slower anyways. So say if you were running out of time, you could have still answered questions 8 through 12 and just not answered question 13, okay? Because you would have maximized the number of correct answers you could have gotten, all right? Awesome. Well, next you are going to do some practice problems with real released ACT tests. Have fun.